Welcome to qnawire.
Question.
Analyzing the given chemical reaction scenario based on the provided solution document. Next, reaction kinetics, determining order and rate constant. Problem overview. A chemical reaction is monitored over time, and data is plotted in two ways: concentration of the reactant versus time, concentration of the product versus time. The goal is to identify the order of the reaction, determine whether the given statements about the reaction are true or false, understand how the rate constant and rate of reaction behave in relation to the concentration of the reactant. Analysis. Step 1, graph interpretation. A plot of reactant concentration versus time yields a straight line with a negative slope. This linear relationship implies a zero-order reaction because, for zero order, AT equals A0 minus KT. A straight line with slope equal minus K confirms zero-order kinetics. Step 2, rate law derivation. For a general rate law, minus a frac D equals Ka squared N. For a zero-order reaction, N equals 0, D8 equals K. This confirms that the rate is constant. The rate constant Ka does not depend on the concentration. Step 3, slope and rate constant. From the linear graph of A versus T, the slope equals minus K or minus. Using data points, initial concentration A0 point text M, final concentration AT equals 0.10, time elapsed equals 10s. K equals frac A0 by TE, frac 0.2 minus 0.10 equals 0.02, text mole minus 1, text S squared minus 1. Thus, the rate constant K equals 0.02 mole L minus S. And step 4, evaluating statements. Statement 1, the reaction is zero order. True, supported by the straight line plot of A versus time. Statement 2, the unit of rate constant is incorrect. True, zero-order reactions have rate constants with units of concentration time, e.g. mole L, mel s, est minon. If a different unit was given, it would be incorrect. Statement 3, if the concentration changes, the rate constant changes, but the rate remains the same. False, the rate constant is a property of the reaction at a given temperature and does not change with concentration. The rate also does not change in zero-order reactions, regardless of concentration. Statement 4, the reaction is complex. Likely true, zero-order behavior often implies a complex mechanism, possibly involving catalysts, surface saturation, or other rate-limiting processes. Final conclusion. Description, verdict. True, rate constant changes with concentration. 1, reaction is zero order. True. 2, incorrect rate constant units given. True. 3, rate constant changes with concentration. False. 4, reaction is complex. Summary. A zero-order reaction exhibits constant rate regardless of concentration. Its graph of concentration versus time is linear. The rate constant is calculated from the slope and does not vary with concentration. The presence of zero-order kinetics often hints at a more complex reaction mechanism.